This is your last topic that's going to be covered in your mid-year exam in week 5. Most of you are doing it on the Thursday in the morning. Some of you are doing it on the Friday because you have a double up for psychology. So the last thing that we talk about is the idea of quantiles. I've shown you how to use normal CDF. That's what we did yesterday. That tells you how much what percentage or proportion of the data lies between the lower number and the upper number. We have to be able to do the opposite of that. The opposite of this is what number does X% of the data lie below or above. We find that with a function called inverse normal. So let me show you how to access inverse normal. You go to distribution again, second vars. Can you see number 3 says inv norm? So we select that. Now, this is the first year that I've had so many people have the newer calculator. Okay? So can you get your calculators out, please? It's very important for me to establish who has the newer calculators, because you have a slight advantage over the people that have older ones. And it sucks because I only have the older one to show you here, but I will talk about how the newer ones work. So if you've got your graphics calculator, can you please open, again I'll demonstrate, second vars. Oh, that's the wrong thing. It didn't pick up second. Second vars, select inverse normal. I'm going to open now, but I have an older calculator. Can I see hands up who has exactly that screen? Yep, the older one, she's got the same as mine. Do people have something that says tail? So you have the newer calculator, okay? You have a slight advantage. People that have the newer calculator, can you set the tail to left?
Yep, it's already on there.
So you're the older calculator. Yours is going to work. Remember how I gave you separate instructions yesterday for normal CDF? Just listen into that. So the people with the newer calculator, if yours says tail, can you set it to left, please?
Yep.
Set it to left. It's going to be up to you if you want to mess around with the left and right later. But for now, I'm going to teach you, because the majority of people have the semi-older calculator. Your calculator, most of this class has a calculator that looks like mine. What does inverse normal want? How does it work? Inverse normal expects 3 inputs. It wants the area, it wants the mean, and it wants the standard deviation. Here, I've illustrated what the area represents. Normal CDF used to tell you what percentage the area was. Now, I know the area, and I'm asking the calculator, what's the number where a certain area lies below? Okay? So literally, when you're doing your questions, if you have a question that says, what percentage or proportion of the data, you're doing normal CDF. If your question tells you the percentage, you're doing inverse normal. If you have an older calculator, you input those numbers as above in brackets with commas. So that's for you behind, I can't say names. That's for you, and that's for you. You put the numbers, area as a decimal, mean and standard deviation separated by commas. If you have a newer calculator, so we've got the semi-newer ones, your screen looks like mine. It wants the area as a decimal, it wants the mean, it wants the standard deviation. After you enter the expected numbers, you press paste, and then the calculator tells you the number below which the entered area of the distribution lies. So I'm going to give you some time. Can you get down to there, please? And then I'll demo.
What is just area, mean, and deviation?
Yes, and the area is the percentage as a decimal. So once again, your working out should tell me what did you put into inverse normal, area, mean, standard deviation. So some time to get down to the star, and then let me demo it. Is this your last day here?
Yes.
Have you seen a koala yet?
No, yet.
Should we go on a little excursion? I mean, we have a lot of koalas there. If it was in my country, we'd find a koala, we'd eat it. We cook it. Why are you smiling?
You probably want to skin it too.
Or a pop. My country, third world country.
Did Brody get the 170?
Hey. Yes, he did. He got 172. He's got a video of it and everything. It was easy. I tried it. I couldn't even get it off the floor. That wasn't anything negative. Just like literally say his name got 170. I think he'd be proud of it. I might upload it. He deserves some kudos on you.
Find out whenever you watch it.
172. A minute and then I'll demonstrate it. So those guys with a newer calculator, leave it on left for now. Once I've demoed this, then you can decide for yourself if you want to do the right. Never use center.
No,
Please don't mess with. Don't use center. It's not clear how that works. But you can use left and right once you've learned what this does. All right, let me demonstrate. Let me talk about the newer calculators. So this only affects 3 people in this class. If you have a calculator like mine that you can see on the screen, or the calculator like theirs, those two, inverse normal only works to the left. Inverse normal only tells you the number below which the area is on the left of it. Okay? That's why you guys set it to the left, because I'm teaching mostly to people with older calculators. You have a slight advantage though, because you guys can set the tail to the right. Question?
Does that mean in exams that would only be left?
No, I'm going to demonstrate one where it's like, we'll go through it now. If you are asked a question to say what number does 40% of the data lie below, everyone's fine. Because you'll just say area is 0.4. Because you care about what's below it. But because your calculator isn't as new as theirs, and your tail is always to the left, how do I work out what number does 40% of the data lie above? We can't do that, but you can think about it. Because if 40% of the data is above something, what percentage is below it?
60.
60. So you can just do the same. We have to do an extra step of thinking. They can set it to right. Okay? So let's do an example. Example, X is normally distributed with a mean of 23.6 and standard deviation of 3.1. I want to find the number where the proportion below the number is 95%. So is that looking for data below the number? To the left? So what would I chuck into the calculator? I would go I would go inverse normal. The area is 0.95. The mean is 23.6. Standard deviation 3.1. That's my working out. So 0.95, 23.6, 3.1. So that tells me for this distribution, the data, 95% of the data lies below 28.70 rounded to 2 decimal points. Okay? If I want to quickly, you don't have to draw this, but I'll illustrate what that's showing you. You had a normal distribution. Where's the middle of this distribution? The middle is at 23.6. And you found this shaded part is 95% of the data, and you found not, they called it K. You found K. What is K? You found K was 28.7. That's what you did. See how we didn't need to do any extra thinking because it was to the left? But if I look at B, do I have to do an extra step of thinking if I have a holder calculator? Because it's asking which is the number where 65% of the data is above it. You guys with a newer calculator, can you set the tail to the right? So you would just set your area to 0.65, tail to the right. We have to think a little bit, okay? We have an older calculator. I'll do B in this area below. B, inverse normal. But because my calculator only works to the left, it's going how much is below. But this question is above. What percentage is going to match that position? 35. So you would go 0.35, comma, 23.6, comma, 3.1. So second, dist, inverse normal, 0.35. So you would say 65% of the data lies above 22.41 to 2 decimal points. Okay? So your homework now, I think it's 5C for quantiles. Just let me check before I stop the recording. (5C), and that's it for statistics. So I will